Well, that's the issue. The James Webb Space Telescope is turning things upside down. Renowned American theoretical physicist Michio Kaku has just revealed an astonishing discovery made by the James Webb Space Telescope that could alter everything we know about the cosmos and its origins. NASA's $10 billion telescope, which was launched in December 2021, has just detected 6 massive galaxies, each about the size of our Milky Way. Yes, a collection of galaxies from the early universe so huge they shouldn't even exist. These galaxies were initially seen as a series of blurry dots, unusually bright and unusually red. The 6 giant galaxies, which hold almost as many stars as the Milky Way despite forming just 500 to 700 million years after the Big Bang, have been labeled universe breakers by the team of astronomers that discovered them. This is because if they are indeed real, this finding challenges our whole understanding of galaxy formation. To explain the existence of such enormous galaxies this early in time would force scientists to rethink the foundational rules of cosmology and how the first galaxies developed from small clouds of stars and dust. The early universe wasn't expected to organize itself so quickly. In theory, these galaxies should not have had the time to form. Scientists don't know precisely when the first clusters of stars began merging to create the early galaxies we recognize today, but cosmologists have estimated that this process started gradually, shaping up within the first few 100 million years after the Big Bang. The discovery of such gigantic galaxies so soon after the Big Bang, however, suggests that the Dark Ages may not have been so dark after all, and that star formation in the universe may have started much earlier than previously believed. Current theories propose that around 1 to 2 billion years into the universe's life, early proto-galaxies reached a developmental stage, forming into dwarf galaxies that began merging and growing into larger galaxies like the Milky Way. Since light travels at a constant speed through space, the further we look into the universe, the older the light we observe, allowing us to peer further back in time. By using the James Webb Space Telescope to look approximately 13.5 billion years into the past, astronomers have discovered that massive galaxies had already come into existence very quickly after the Big Bang, at a time when the universe was only 3% of its current age. These galaxies, appearing to be about 13.5 billion years old, were formed roughly 500 to 700 million years after the Big Bang. Based on our current models, these galaxies shouldn't have had enough time to come together. This forces us to reconsider everything we know. The galaxies are so large that they conflict with 99% of our cosmological models. This means either the models need to be revised, or our entire understanding of galaxy formation needs a major overhaul. Either way, it's a groundbreaking discovery by the Webb telescope. The Milky Way forms 1 or 2 new stars each year. These galaxies, by contrast, would have to create hundreds of new stars every year throughout the history of the universe. Furthermore, these galaxies seem to contain up to 10 billion times the mass of our Sun in stars. One of them could even hold the mass of 100 billion suns. If even one of these galaxies is confirmed, it would challenge the very limits of our knowledge of cosmology. At present, all signs point to these objects being galaxies, though astronomers have not ruled out the possibility that some might be massive quasars or supermassive black holes. Earlier observations of the early universe by the Hubble Space Telescope did not detect these massive galaxies, but the James Webb Space Telescope, JWST, is around 100 times more powerful than Hubble. The Webb Observatory was designed to uncover the earliest periods of the universe's history in its faintest flickers of light, and it has been fulfilling this mission ever since its launch. This isn't the first time the Webb telescope has made us rethink our cosmic understanding. Just last year, it made a revolutionary discovery related to the Big Bang theory. Rowan Naidu was at home when he stumbled upon a galaxy that nearly turned cosmology on its head. As his algorithm combed through early images from the James Webb Space Telescope, it identified an object that, on further investigation, was incredibly massive and dated back to about 300 million years after the Big Bang, older than any galaxy ever observed. At that moment, Rowan realized it might be the most distant starlight we had ever detected. Days later, he published a paper on the candidate galaxy, which was named GLASS Z13, and it quickly gained attention online. The remarkable discovery of this galaxy, just weeks after Webb became fully operational, exceeded astronomers' wildest expectations. The cosmic dawn, once thought to be dim, now seemed like a vibrant cosmic afternoon. Over the weeks and months that followed, Webb's surprising discoveries of early galaxies caught theorists off guard, leading to a rush to explain these findings. Could these galaxies indicate that the universe is far more mysterious and complex than even our most daring theories have predicted? What's at stake is nothing less than our understanding of how the structured universe we know came from primordial chaos. Hubble previously held the record for the most distant galaxy ever observed, GNZ 11, which was discovered in 2015 at a redshift of 11, following a 2009 upgrade that boosted Hubble's infrared capabilities. A redshift of 11 represents a cosmic age of around 400 million years after the Big Bang, marking the edge of when galaxy formation was thought to begin. But Webb's early discoveries might be about to rewrite the early chapters of cosmic history, chapters that affect not just distant galaxies and epochs but also our own existence here in the Milky Way. You build these instruments not to confirm existing ideas but to challenge them, said Webb scientist Mark McCaffrey at the European Space Agency. You just don't know how they'll be challenged. As light from distant galaxies travels across the vastness of space, it is stretched by the universe's expansion, a phenomenon called redshift. The higher the redshift, the more stretched the light is, meaning the galaxy is more distant. The redshifts for these early galaxies are so high that their visible light has stretched into the infrared by the time it reaches us. With Glass Z13 at a redshift of 13, this places it at around 300 million years after the Big Bang. Could galaxies have formed this early in the universe? While more research is needed on these primordial galaxy candidates, scientists hypothesize that smaller galaxies could have developed early in the universe, which might explain the existence of Glass Z13. Little did they know, Webb was just beginning to unearth the universe. Over the next few days, numerous galaxy candidates from source and glass appeared, with redshifts as high as 20, around 180 million years after the Big Bang, some with structures resembling disks that were not expected to form so early in cosmic history. Now, an unprecedented discovery has been made, revealing cracks in cosmology. While examining a section of the sky near the Big Dipper, astronomers identified 6 faint objects dating back over 13 billion years. These objects are thought to be ancient galaxies. Such early star systems were expected to be small since they hadn't had much time to grow, but these galaxies are huge. It's astonishing, as the red, bright objects in the Webb data could contain billions of stars similar to those in our Milky Way. These galaxies, formed just 500 to 700 million years after the Big Bang, exist in a time when there shouldn't have been enough matter to fuel such an explosive growth of stars and solar systems. The distant galaxies appear as fuzzy red objects because, as the universe expands, the light from them is stretched, shifting to longer, redder wavelengths. The research on these galaxies is only in its infancy. There's a possibility that some of these red masses may actually be other kinds of primordial objects, like quasars, super-hot, energetic matter circling a black hole and emitting immense amounts of light into space. However, we remain unsure of many mysteries about the universe. One thing is clear: the birth of the universe is now under close scrutiny. And whatever Webb's data reveals, let's hope it leads to a more accurate origin story of the universe. After all, science is all about evolving our understanding. What do you think? Share your thoughts in the comments below, and don't forget to subscribe to the channel, because together, we'll keep exploring.